This conference will now be recorded.
All right, hang on. Let's get the correct screen. And there we go. Hang on just a second. We'll get this correct. Now you should be seeing all right. Can everybody see with a thumbs up my first screen that says Surat Tech Talks, very big?
Yep, we can.
And it just went away. So hang on one second.
Sure.
We'll get this straight. There we go. Now you should see it again. Okay.
Yes.
Yay. Okay. Surat Tech Talks. Wonderful. And just let me know if at any point you're not seeing very big graphics on screen. Everything should be working just fine. I want to make sure you see it well. Well, here we are, and we're talking about the science, psychology, and secrets of great UI. So let me start with a story. Now, we live today in a golden age of computing, connection, information. This has all been made possible by developers, by engineers, by us. It wasn't that long ago that the world looked like this, right? We had room-sized mainframes where we saw how the world was essentially organized from a computing perspective. Engineers all invented this. Everything was new. Every bit of code we have today, every bit of hardware and software had to be thought out, had to be invented, and it was. It was done so by engineers, by developers, by technical people. And soon we had computers in the home. And if you are sort of a nerd or a geek like me, like we call ourselves in America, we were able to do amazing things. And because we were able to start using computing and start programming and making software, different types of ways of interacting with computers and systems and software evolved. What we ended up with were new disciplines. And these disciplines were about interacting with a computer. They were called HCI, or human-computer interaction, human factors, or one of my favorites, usability engineering. Usability was always associated with engineering from the beginning. And over time, as our technology got better and our interfaces got more sophisticated and popular, new types of ways of thinking about interfaces started to emerge. And you get Xerox and the Mac and the drag and drop interface. And suddenly things start to change because you start to get people on the right brain side or the creative side or the humanities side start to think an awful lot about interfaces. But we're still thinking about usability as an engineering discipline. Later in the 90s, early 90s, things really change when the web shows up. And early web was, of course, very, very rudimentary, not sophisticated, but something new happened. When the web became popular, creating great interfaces suddenly became something that was done by engineers and developers and other types of people, creative people, writers, designers, information architects. People who never had to work together that much before are now working together a lot. And slowly but surely, the web matures to where we come today. We have huge expectations for things being super simple on the web. We have a blurring of applications and websites. We're creating amazing online software, creating wonderful mobile software. We're moving forward very, very fast. And this notion of how to interact with computers, how real people interact with computers, is slowly became the province of creative people. Engineers and developers thought less and less about this and focused more and more on programming. So now we have nearly everything happening, right? We've got all sorts of health apps and home automation and learning. And we have the Internet of Things, where our interfaces are exploding into all other areas of life. I'm going to argue today that in this process, developers, engineers, technical people like us have lost something in the translation. Over time, we've stopped talking about human factors or usability as a discipline, and we focused almost exclusively on the technical and the functional. And other people are thinking more about how something is used and how something is made efficient and how something is intuitive. The principles are just not taught anymore. And so as user experience as a discipline has evolved, UX has evolved, a developer or an engineer's sense of what makes something usable has lessened. And that's a problem for us. So because we have to work side by side with creative people when we're creating software or interfaces now. So today what I'm going to do is talk to you about the science and psychology, the secrets of great UI. This is part of a discipline that used to be known and familiar to engineers and now is not anymore. And we need to reclaim that. So we're going to do a little bit of that today, and it's going to be kind of fun. And I'm going to prove a few points to you today. The first is that UI is measurable and scientific. It's quantifiable, it's predictable, it's even mathematical, I promise. We're going to talk about UI rules that apply across technology. No matter what kind of new technology emerges, there are rules of interface that apply all the time. They apply in software, they apply in web, they apply in client server, in mobile, in AR, and VR. Later, they'll apply to holograms. There are rules that will last. I also want to encourage you that UI is something you can understand and that you can actually do. That's really important as developers and engineers, as architects. We need to understand that UI is not something that's just for creative people at all. It's totally for us. It's for you. So let's dive right in. The first thing I want to explain is that great UI is not subjective. A lot of people think that UI or GUI interfaces are things that we make after something has been built. We think it's beautification after the fact. It's something you add after functionality is done. It's completed by creative people in a weird creative black box. And that can't be further from the truth, because UI or GUI is just the tip of an iceberg of everything we make. Underneath is all of the deep function, the deep thought, the deep planning, the deep structure, all of which affects a user experience. The UI, the GUI, it's just what we see. That's it. It's just what a real person uses. It's not the main effort. It's what we can see. Now, in America, we have a saying. And the saying is, you cannot put lipstick on a pig. A fancy red bow can't make something horrible better. You can't just add something pretty to a terrible thing and suddenly make that thing perfect. It's just a pretty bow on a horrible thing. And that's a poor experience. And we need to be trained to understand how to create something with a unified view of user experience, of design, of function put together, because that's how great things are made. No one makes a great vehicle or car by building it and then making it beautiful. All of it happens at once. So let's unpack this. This is a horrible website from a school of art. Now, it's obviously terrible. The question is, why is it terrible? Why do we look at it and say, oh, that's so bad? Now, this particular site is being bad on purpose, but it's violating a lot of rules. So we're going to talk about why this site is different. Why we look at a site like this and say, ah, well, that's better. I can find things more easily. I can detect what I need to do. I can accomplish a task. Why? There are reasons for this. So today we're going to dive into a bunch of the reasons why an interface like this works, because there are objective reasons for it. First, I want to focus on how we as people interact with machines, because who we are as humans has a great impact on how we interact with technology. And of course, we like to think of ourselves as wonderfully brilliant and amazing, but we're really very, very limited. You might not feel this way, but it's true. We're quite bad at things like seeing, remembering, and understanding. We're terrible at it. So let's unpack it. First, our vision is poor. I have my glasses on right now. We don't see as well as other species. Right? Our eyes are adapted for movement, but not for accuracy. So we have very poor peripheral vision. We can't see things very well out of the corner of our eye. We see things right in front of us only. We have a very limited range in which we see well with accuracy, 10 to 30 degrees right in front of us. Everything else, we see movement, but not reality. Example, say you see a car coming at you. You imagine you see everything in this picture or everything in this scene. What you are really seeing is this. You are seeing the car itself, and everything around is either blurry or uncertain. Your brain is actually interpreting this for you. It remembers things it's seen seconds ago, and it fills in the gaps. Your eyes do not see what's over here. Your brain is interpreting it for you. So what does this mean for digital products, for interfaces? Well, as it turns out, quite a lot. So let's say we're doing something simple, like we're shopping for shoes, and we see an array of shoes on our screen. Well, we're not actually seeing everything on this screen. We're seeing a little piece of it, the piece that we are directly focused on. Everything else is a little blurry. Our brain is sort of interpreting it all, but our focus is very small and very direct. So when we make interfaces and we deal with tasks, we know that people are like this, everyone. Think about a simple form. When you hit the submit button, your attention is down at the submit button. If you get an error based on a submission, and the error is difficult to see, it's not very prominent, it might be missed. And you might wonder, is the form broken or what's going on? Because your eye sees something blurry. It sees something a little bit like this. And when you think our focus is all in one place, you can miss everything. That's why when forms are created, a UX professional knows this about people who have bad eyesight. And that's why standards have emerged that say that errors must be enormously prominent, extremely visible, very proximate to the place at which they occur, and it's best if an announcement tells you there's an error. These are all based on real physical attributes of human beings, because if we don't quite see something well, we need in our peripheral vision to see that color that tells us something's wrong. And if there's more of it, we can see it. Well, what about our brains? Our memory is actually not quite good. We think we remember things about events or experiences, but often they don't happen the way we think they did. Our brains fill in gaps in memory over time. This is why in a court system, especially in America, you need 2 eyewitnesses to prove something. You can't trust what one person says they remember about something. Now, our short-term memory is particularly bad. We don't remember things for a long time. So if you were looking at a variety of symbols like this, and I asked you to try to remember them, and then I took them away, they were up for a short time, how many could any one of us remember? The answer is very few, especially because those symbols didn't have words with them, and there were about 10 of them. Most of us could remember 3 or 5 of them, maybe, but nearly all of us would fail at trying to remember them all. Our short-term memory is very, very bad. This is why voice interfaces are so basic, especially right now. They ask you one question, or there's one prompt, and you have one answer, followed by one more thing. Because if we had too many things in our brains, we can't process them well, efficiently, quickly, or we may make mistakes. All of those things are terrible for usability in interfaces. There's a law about this limited capacity. It's called Miller's Law, right? Our working memory can't hold a bunch of things in mind. So what this law means is that excessive choice creates confusion. How do I know which particular blue circle to pick? Because they're all relatively the same and there's a lot of them, right? The more items we have, the harder it is to remember. Well then, how in the world do we learn as little children how to talk and how to write and how to learn letters and numbers if they're so hard for us to learn? In America, we have a 26-character alphabet, A through Z. And there's 26 characters routinely. Little children, 3 years old, they'll memorize this. Well, how can they do this if there's so many? And we know Miller's Law is a real thing. It's very simple. When we teach young children how to speak or how to think of their alphabet, we sing it to them. Say A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. Now I know my ABCs, next time won't you sing with me? And a young child can get that beautifully. And they've just learned a huge amount of information. So I ask you, when was the last time someone sang your software? Someone sang your interface? The answer is, of course, never. They never will. They never work that hard to understand the things that you are making. So you need to understand how limited people are. It affects how many things you put on a screen. Let's think about this intranet, for instance. This is a real intranet that my company worked on. And in the beginning, it looked like this. There are massive amounts of links, buttons, ads, and information. There's so much here you could barely grasp what it is. There are even a big drop-down list of a million other options that can't even fit in a large drop-down. There is so much here that people's brains can't process it easily, and usability suffers. It takes people a long time to find things. They can't find things. They don't remember where things are, and it is just awful. The redesign looks like this. This is the same information, the exact same intranet re-envisioned. Prioritized tasks are large and clear Everything is simple. There are few things to do. It's easy to look at items and understand what they are. There are real reasons why this interface is better. So let's explore them a little more. Let's remember that interface we looked at a few minutes ago as well, which is from a similar site. Why is this interface easy to understand, whereas others are not? Well, first, let's look at how we're grouping information. We see, instead of a huge list of links, really we only see 4 columns, each with a header. I can handle looking at 4 columns to figure out what's below. That's easier, that's simpler. I don't have to look at all the links and figure out the one I want. I can just figure out which column is like what I want. So by grouping things and making it feel like there is less to look at, I'm obeying Miller's law. Now there's some other laws that are very important about how we perceive interfaces. One is called the serial position effect. This basically says that we recall items at the beginning and at the end of a series better than anything in the middle, right? Consider these shapes. These could be voice commands, they could be shapes, they could be buttons. If we give each a different label, A through E, the American alphabet, we are going to remember A and E first. We'll remember those over anything else. We remember the first, we remember the last. This is absolutely scientifically proven. There's a great deal of evidence surrounding this. So, given the fact that we know this, what would we do in an interface? Let's look at that screen again. Let's look at the global navigation. Now, we know for a fact, based on user studies, research, and analytics, that the 2 most important things on this site are patients and visitors and find a doctor. So where did we put those things? In the main navigation, we put them at the beginning, we put them at the end. We know those are the places they'll be seen and remembered most readily. We're just following the rules of psychology and science. The same is true of a voice command interface. If you call a company and they have a voice list of options that you need to choose from, and they give you a bunch of options, it's hard to remember them. But you may remember the first one, and you may remember the last one better than anything else. That's just the truth of that effect. And it helps you understand how to make things. Well, let's think of another thing called the von Restorff effect. We're more likely to remember items from a complex series if they are similarly highlighted. This basically means you remember the thing that's different when you look at something. There are a bunch of words or verbs. We see drive first. Our eyes go right to it. We can't help it. Our brains will do that without us thinking. It stands out. It sticks in your mind. This is why the hyperlink was essentially created as it was. It obeys the von Restorff effect. It's different from everything else on the screen. It is obviously easily findable and always identifiable quickly. That's why the hyperlink was made. Well, another problem with humans is something called cognitive overload, thinking too much. If we give people too much thought work to do, they'll usually fail. Our brains can't handle anything, sorry to say. Now, I've got an animation coming up. This should go well over internet. If it doesn't, don't worry. I'll show you the whole thing in a moment. But this is a site, AT&T, and it's about choosing movie packages that you might want for a service. And there are a lot of options in this package. And right now, what you should be seeing is a large scrolling list that goes on forever and ever and ever and ever. How could you possibly absorb and process all of this information quickly? The answer, of course, is you cannot, even when it's organized very well. And to give you a quick idea, that's how long that screen was with all these ridiculous amounts of options. The more we have to work and think about something, the more likely it is we'll make mistakes or have problems or be slow. Let's think about a complex list of characters, right? This could be a software key or a password or a sign-in number. Let's look at this. This is hard, right, to remember and to even look at. If you had to write this down, you'd have to look at it a lot. But if we add simple dashes in between, now it's just 5 sets of 4, much easier to look at. If we highlight those things a little bit, even easier, because we know that when people have to work too hard and think too much, problems happen. They go slower, they make mistakes. But if you open things up for people, it works better. This is true of video conference software, right? If you have a dial-in number that is a bunch of characters, I think this is 9 or 10, it's hard to tell, they're all put together, and you have to type them in, you'll probably look back at this number several times to make sure you get it right. And you might still make a mistake. When you pack all those numbers together, you have to think too much. So if you just do something different, right? Like perhaps GoToMeeting does. The access code for dial-in is separated by dashes. Same number of characters, but now it's 401, 041, 421. 3 sets, easier to say, easier to remember. If you had to type it in, maybe you'd look at it twice. Much faster, much easier, less thinking. So what does this mean for interfaces? Well, imagine a grid, very common in software design, right? Grids are something we need desperately, but they present problems, right? When you show dense data, you risk cognitive overload, right? Now, this grid minimizes those problems by adding those rows, alternating rows. That's why we have them, so that people can see things quickly and easily. We've even highlighted the left column, which is the most important column here, so that at a glance and fast, you can see and find what you want. Now, I'm scrolling this right now, and it has a certain problem. It's that the top row goes away when we scroll, and I can no longer remember what every column really is. Well, what if instead of doing that, we scrolled but froze that header column? Now I don't have to remember what the 4th column was. What is that date? The difference between rent begin and move out. It's too hard for people to remember things. They're terrible at it. So we give them legitimate help so they don't have to think. This is true of something like Outlook. There are so many things happening on this screen that remind us where we are, what we're doing, what we've read, what we haven't read, where we are in how we're looking at something, what we're looking at right now, because the human brain can't fit all that in one place. We just have to have constant reminders. Where are we? Where can we go? Where have we been? Always, or else we have to think too hard and your interface will fail. We also, unfortunately, don't learn easily. Humans have something that you might have heard of called mental models. We have a way of perceiving the world around us. And when we find a specific mental model, we love it and we keep to it and we judge the world by it. And anything that violates that mental model feels odd and weird and hard to understand. So imagine a car, all right? A mental model that people have for driving a car is a steering wheel. Almost certainly you're not going to make a car without a steering wheel. We know what it is. It's a mental model. I hold a circular thing and it turns the wheels. I know this is true. I don't have to be taught it. I've developed a mental model. Well, interfaces have mental models as well, and you cannot violate them because people have built up a way of thinking about how things work digitally, and you have to fit within that. Think of something simple like the web. There are basically 3 things about the web that even the most novice user understands. I can link to different places with hyperlinks. I can scroll up and down. There's more stuff below. And there's this thing called the back button where I can go back to where I was. These are things that people understand about the web. These are mental models that you cannot violate. You have to follow them. Never break the back button. Users of all sorts, novice, intermediate, and expert, use it all the time. Don't break it. Well, think of other models. This is a hamburger menu, right? It was created by UX designers to help make navigation work better on mobile devices. It took a long time for this to become obvious and accepted as mobile navigation. There's more of it. It really didn't happen quickly. And we saw early on tons of people have trouble. Over time, it will become a mental model and it will become obvious. It's still not quite there. We still see users fail at understanding what it is, even today. So mental models are slow. People also have a short attention span. We know this. That's why information is presented in little bits and nuggets. There's an old Jira interface. It takes a lot of concentration to handle this interface, especially when you're new at it. This is an old Jira interface, obviously, and here is an old software interface. Tons of software has looked like this, tons of it. It takes a lot of attention and time and concentration to understand what's going on. This is why people must be trained on software like this, trained in order to use something. If you have to do excessive training to use a digital product, there's something wrong with your digital product. Training's not bad, but excessive training, repeated training, it's a danger sign. Few more points. Humans are not rational. I wish they were, but all of our users, they don't think logically about the things we make like we do at all. Let's think of ourselves as humans who have a brainstem, and this controls our base fight or flight, primitive, unconscious actions. Well, we also have this other part of our brain right around that all mammals have. It's this part that governs our emotions. This is the section of our brains that dominate when we're frustrated, when we're mad, when we're impatient. All right, this is the part of the brain that people are using all the time when they're using our interfaces. Hugely important to understand because we have this prefrontal cortex, the big part of our brain, also the newest in terms of evolution. It controls logic, reason, decision-making, all the things we want people to be thinking about when they use our work. But when they're frustrated, this part of the brain is physically and actively shut down, and we revert back to the mammalian brain. That is why Dean Schuster is a very logical, reasonable, rational person, except when he uses interfaces like this, except when I'm trying to pay my taxes online and it's difficult to do and it's hard to understand and it's frustrating and it gets me angry and I stop being rational and then things get harder to figure out because I'm using that part of my brain that is so deeply angry at being frustrated at an interface. It's important that we know this about people. These are also more parts of these horrible content interactions. And when I have these horrible interactions, I'm not thinking about the reasonableness with which you created something. I'm so angry that I'll make mistakes. I will choose another service. I'll go away. And obviously that's not what we want. Okay, deep breath. Now, fortunately, you can do something about all of this, as we hinted at in just understanding something about our brains, but there's also rules about UI that you can know. And this is the exciting part, because anyone can know these rules. So let's start. Well, first let me say the rules are proven scientifically. Everything I'm going to show you by testing and observation. These are facts, not opinions. So let's go on and tell a little story. This is the logo of a band you may have heard of, the Rolling Stones. And they're made up of musicians who could not read music. This is Keith Richards, the guitarist of the Rolling Stones. He has written most of the band's songs. He's innovated and popularized new ways to play the guitar. He's always been an intuitive, artistic player. He cannot read or write actual music, yet he plays, yet he has been successful. Real music is kind of like a language. It's kind of like math or science, right? It has rules to it. You don't have to be an artist to understand the rules of writing music, although some artists can write and play without knowing the rules. They're intuitive, understood. But there are rules. You can read, write, and play music even if you are not an intuitive artist. Music is open to right brain and left brain people alike, to creative people and to engineers. So let's think about interacting with screens, keeping that in mind, because UI is like music. You can learn the theory, and in so you can do the practice. Let's think of a law called Fitts law, all right? It's a real mathematical law. It tells us how size and distance in an interface affect how we use it. Real math, I promise. This is the equation. Basically states that the bigger and closer the element, the faster and easier one can find and interact with it. If a thing is small and far away, it takes longer to interact with and get to. So let's look at our image here. Several objects on a screen. Cursor is in the middle. It is much easier to get to the big green dot than it is to get to the small red dot. Small red dot is small, it's farther away. The green dot is big and close. I will get to that one faster, easier, quicker, and with fewer mistakes. That's a mathematical law, and there's no question. It governs how fighter pilot interfaces are designed. It means that big things that are important have to be big and close. Well, let's think about interfaces. I mentioned that fighter pilot planes and airplane interfaces are created with this in mind, but also just simple interfaces that we use every day. Any OS that we use, Windows, Unix, Mac, they all obey Fitts law because they've figured out one very important thing early on, that if the size of an object were big enough, it would always be super easy to get to, right? It's huge, easy to get to. Well, what if the object were infinitely big? Wouldn't it be the easiest thing on a screen to get to? The answer is yes, because look at the edges of the screen. You know, when you move a cursor and you move it all the way to the edge of the screen, your cursor stops, and no matter how much you keep moving that cursor, it stays where it is. In other words, effectively, a thing at the edge of a screen is infinitely big. You can scroll forever and you'll still be there. That's why elements hooked up to the sides of a screen in an interface are in fact the quickest and easiest to get to. You don't have to have a lot of accuracy to get to them, and you can get to them fast. They obey Fitts law. That's why they work. That's why interfaces are created like this. No question. Hicks law is another one. The volume and complexity of choices affects the time it takes to get to that choice. Simplify. That's what this law means. Make things as simple as you possibly can. There's real math to this as well. Fewer options make for faster decisions. That's it. And that's essential for software and digital products, right? Our response time is faster if we have fewer things to look at. We might be ordering from a menu. This is just a pizza menu. I might take a long time to decide what kind of pizza I want from this menu because it is full of options. I might have no problem, I might not make a mistake, but it'll take a while. If you think of old ribbon interfaces from old Microsoft style software, it's full of choices, too many choices. It just means it'll take time. This is true of old style software, which is still everywhere. Tons of things on a screen means it takes more time to sort out, it takes more time to get to. Almost certainly, you have to be trained to use this interface. This is what Google got so right in 1998. They did one thing, and you've probably heard this example before. Now, Google does a lot of stuff, but of course, they make things as simple as they can. Consider this interface. This is an interface we made for a very simple site. All it does is has 4 options at the top, a couple of small options, and only one thing, one statement in the middle. We kept every bit of complexity out of this and focused only in on the one thing that actual users of the site cared about. And as we were able to do that and simplify, they accomplish tasks and get through what they need to do here super fast. And that's what we were after. Totally works. When we make things in interfaces, we group them. And this is really important for us as engineers and UI professionals to know how to put things in certain places on the screen. And there's rules for this as well. The rules specifically state that when we group things in a certain way, we can understand them better. This is called Gestalt theory. Patterns help us to see things well. And as soon as we put things together, our brains figure them out very well. Consider a law of proximity. When things are close to each other, they feel related. So we have a bunch of stars here, just a group of stars. But if we put them visually like this, no longer a group, now it's 3 rows of stars. Your brain will see the rows instantly, you can't help it. If we go and look at an arrangement like this, you'll see 2 groups of stars now, one a little bit bigger, one a little bit smaller. Same thing works for columns. Your brain will see this pattern so fast you can't even stop it. And all we did was put things close to each other and put space between them. That's it. So this was a huge failing of the old client server days, right? Where we had to pack everything into small interfaces, and we tried our best to put boxes around them and to set them apart, but we failed all the time at it. There's too much, there's not enough space, there's no proximity going on, and so it's hard to understand and slow. That's why an interface like this simply sets things apart. How much you owe versus the details of payment are separated spatially, so they're quick, fast to see. We relate payment details together because it's encased in a box, fast and at a glance. The same thing is true of text. When you're trying to read something online, you need to understand what goes with what. Here we have titles and paragraphs, but it's hard to tell at a glance where the title goes. Is it a title of a paragraph below, or is it associated at the end of something above? We don't know because the space is all the same and there's no good proximity here. If all we did was simply put the titles closer to the paragraphs they're associated with and offer space, boom, 4 paragraphs, titles are clear. That's proximity. Proximity works for simple interfaces like this. We simply put like things together and we separate them by space and layout, and they're easy and fast to see, and we see contact information as one thing, other content as other, and it works very well. A few more rules before we're done. Similarity. We see a group of shapes here, and they're just squares and circles. But if I change the groupings and make one set dark and one set light, we see dark and light. We don't see necessarily circles and squares first. So it's good to know that when we put things together in similar color, they become unified. So all of the links in this interface in the blue area are clearly associated with each other, and they're alike. They do a similar thing. That's why we put them there. Well, there's other fun principles. Continuity, right? The human eye follows paths. We don't see a collection of dots, we see a line of dots, because our brain is great at seeing this. It's very important. We don't see 3 boxes, we see a progression, XX check. This is why progressions about steps in a process work because we see the progression. We know it's a progression. Our eyes understand it to be so based on rules of how we perceive shapes and layout. It helps us understand that's why this works. That's why people use this interface convention. One of my favorites is the closure illusion. Our brains interpret shapes even when some of the parts are missing. So if you look at this particular image of 4 triangles, what you'll see also is a square in the middle. There is no square in the middle. It's an implied shape. Your brain sees it. Our brains are good at this. So we can use this in interface design. The best way we use it is in mobile, because closure means there are items at the bottom of a screen. And when you hint at the fact that there's a shape below the scroll line, your brain instantly assumes that shape goes further, that shape keeps going and is similar to other shapes. It tells your brain that there's more below. And this one principle dominates design of mobile interfaces. We know it to be true and we use it to great effect. And it's proven time and time again to work. Connection and union. We can connect things and make them similar. So we have a bunch of squares, we put a little box around it, and that box becomes one thing. This is why whenever you have, let's say, a bank or login at services, it's encased in a box. Because we know that once we do that, it becomes a separate thing. It's also become a mental model. So it has a double advantage. Okay, now that was a lot of stuff, but fun. And there's so much more of it. So let me tell you how you can get to understand all of it. It's important to know that these principles of great UI are knowable. They are not a mystery. There's nothing special about anything we talked about. You can do it as a developer, as an engineer. Because our job is to not have subjectivity. Everyone has an opinion about how something looks. No one can even really define what art and beauty are. It has a different feeling for everyone. But digital products must be governed by objectivity. They always will be. So it's important to know the rules. It's important to study these rules that we've talked about a little bit today. And you can do that by going to these sites, interactiondesign.org, uxmyths.com, lawsofux.com. These are really amazing sites that go through all of this stuff and much, 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 much more than we talked about today. And it's amazingly interesting. You could also read some books. Here are 3 books you can read. Designing with the Mind in Mind, The Amazing Design of Everyday Things, and Visual Thinking for Design. All of this is all about how our brains work and how psychology affects interfaces. If you had to only do one thing and read one book, Designing with the Mind in Mind is the book for you. It is all about what we've talked about today. It's written from an engineering perspective, and I think you'll enjoy it and learn quite a lot. And if you do this, you will become a stronger developer. You will be a better teammate. You will gain deep respect from your organization. And you will be able to call out terrible UI because you'll know why it's terrible and you'll be able to discuss it. And that's very, very important. Now, what we're looking for on the understanding and respect side is simple. Most of us as developers and engineers, we agree, of course, that it would be so much easier to make digital products if all the non-technical people we talk to, writers, designers, UX pros, whatever, stakeholders, leaders, if they just understood the basics of code and development, we could talk and we could get things done easily. We all agree with this. We so wish they would be able to do this. The opposite is also true. Making great digital products would be much easier if engineers understood the basics of design in usability laws and rules. And if you know them, it's like gaining a superpower on a project team, and you can totally do it. Thank you very much. That's it for me. Again, my name is Dean with True Matter is my company. We do UX all the time, all day, every day. I have a blog, blog.truematter.com, where there's tons of articles about all the stuff I just mentioned. Not selling anything, just great stuff to learn there. And it's a great way for you to think and learn more about UX. Great article there is called Why Development Teams Fail to Make Digital Interfaces Well. It'll touch upon many of the things we deal with and many of the problems we have as engineers. So I think you'll enjoy that as well. So thank you very, very much for your time, and I hope you have a lovely evening.
Thank you very much, Dean. This is very, very informative session. Sorry for that echo. Yeah, this is very, very informative session. Now let's open the Q&A session. If you guys have any question, you can unmute yourself and ask your question, or you can also put your question into the chat window.
I can make my notes available to the conference organizers, by the way, if you need them. I'm sorry, go ahead.
Yeah, then this is Tejas over here, one of the co-organizers of this event. It's
Hi.
nice to really enjoy your session over here. The question I wanted to ask is not about the UI. The question I wanted to ask is, can we have a series of talk of yours over here? Because these were really informative, and the way you covered and explained everything, it was like it was a vocal UI design, right?
Yeah, I would love to keep talking with everyone about this. This is a mission of mine to help developers and technical people reclaim an understanding of usability and interface that really was something that engineers thought of in the first place.
Yeah, so I don't know whether you know about Surat as city or not. So Surat over here, it's basically a diamond capital of the world. 70% of the diamonds of the world are polished in Surat.
Very cool.
Right, and we are also like the best place for textile industries in India, at least. And lots of textile designs are done and manufacturing is done over here. And now we are also rapidly emerging as one of the IT destinations, that is the information technology destination in India, at least. There would be around 1,000 organizations working in the field of information technology. So your continual talks on this thing would be definitely encouraging us to develop a better UI products, right? So definitely we would be interested in more talks of yours.
I would love to help. I think that would be a lot of fun.
Yeah, thank you. So please share book. Yeah, so this Brijal, he wanted to know the book links and all those things. So I'm sure you would be sharing your PowerPoint with us, and then we will be forwarding those things to the participants. So in that case, yeah, that would be great. Okay, I don't see any other questions right now. That means it was really, really a lucid kind of talk, and everyone's got everything out of it, and they don't have any questions. That is a big achievement. So,
well, have a good evening, everybody. Thank you.
Yeah, you have a great weekend yourself, and yeah, can you please share some, one question has come, can you please share some key points regarding UI UX for software development professionals? Vaibhavi Vani, I think you need to go, we will be posting this video once again on our website,
Yeah.
So you can go through all his lecture once again. What he has covered is basically what you are asking for.
Yeah,
And
and
in
I will share my links to the websites and to the books with my presentation, so that will be available to you. That's a good way to help. It's a great way to start.
yeah, and he will be also available for further talks. So definitely
Yes.
we will be learning more.
Yeah, I
Uh,
have a question.
sure.
Hi, Saga here. So basically, I had gone through whatever the design principle you explained, but when we want to implement that principle in our application design, it just become a bit exercise to implement that into the web page or into the mobile application. And when we really want to do that, it sometimes I feel a kind of disconnect between the actual principle and implementing into the design.
Yes.
Can you guide on that?
Well, there's a couple of things that you might be encountering here. One is going from theory to practice. That can be difficult and it takes time. It takes time to grasp a theory and to be able to practically apply it. Part of that is time, training, experience. You also might be experiencing a process problem whereby the way in which you design and think about UX or UI for a digital product needs some rethinking. So for instance, if you haven't put a lot of thought to these principles of UX early in your planning process, the problems will show up later and they'll be very hard to fix, very hard. And there are situations where even if we know what's right, if it's too late to implement because it's not technically feasible or database decisions have been made or business requirement decisions are already done, that you can't put a principle in place. So one side is process, one side is experience. And from a practical perspective, the best way for you to know how to go from theory to practicality is to have people who understand these principles on your team. And that's happening more and more and more and more organizations, that they're getting UX expertise right in with development teams. Ultimately, that will make the practical application of this theory much, much easier. For developers, I do think it's enough. You don't have to become a UX professional. You simply have to be able to understand and talk about these principles. It sounds like you're already there, where you're understanding something is not right, and you might even see why theoretically it's not right. But getting it done practically is another thing that has to do with organizational dynamics or time or feasibility or just questions. What does this mean for my product? I wish I had a better answer for you. But apart from looking at a specific thing.
No, but that was a great answer. And Sagar, I had mute your microphone. So if you are speaking, please unmute yourself first, and then you can continue asking.
Yeah, yeah. That was pretty much close, like what I am used to practice over my implementations. So majorly we try to cover understand the things on the perspective by the perspective of the user, and we know the rules. But this was the thing. I think the practice will make me perfect in that.
Yeah, you'll get there. Just keep doing it. The best thing I can say to developers is if you're thinking of users and the rules and UI, you're thinking the right way, and over time you will get there. It's especially easier to get there if your organization also shares that value. So I hope you'll be able to have both of those things.
Sure. Thank you.
Tajesh, I think you're muted.
Yeah, I got it. I just said thank you at the last.
Oh, thanks.
Yeah. So as there are no more questions now, I would like to formally thank you and conclude these sessions. I would be expecting you in the next episode of our Surat Tech Talks, which is going to happen in a couple of months, and we will surely be continuing to be in touch online on your Twitter and other handles. And
Great.
thanks once again from my side as well as all the audiences, and thank you all the audience also for attending these sessions in this good weekend evening. Thank you all, and you all have a nice weekend. Bye for now.
Bye.
Bye.